Hello everyone, today we're going to be discussing similar figures. So how do you determine if two figures are similar? So to determine if two figures are similar, we need to compare their corresponding sides. So for instance, a corresponding side is a side that is the same as the other in each image. So we have triangle ABC and we have triangle DEF. In triangle ABC, we have one side as 6 feet and one side as 10 feet. In triangle EDF, we have one side as 3 feet and one side as 5 feet. And we're trying to determine, are they similar? In order to do that, we have to compare the two. So I have to compare AC, which is here, to DF, which is here, and AB, which is pink, and DE, which is in blue. So AC here, again, like I said, is 10 feet, and I highlighted it in yellow here. And then AB is pink and it's 6 feet. And I'm comparing it to DF, which is 5 feet, and DE, which is 3 feet. So like we've done previously with unit rate, we need to figure out how do we go from 6 to 3? Well, you can go from here by dividing by 2. Is it the same for the other side? Divided by 2. 10 divided by 2 is 5. So yes, these are similar figures. Since 10 and 6 equals 2 times 5 equals 10, and 2 times 3 equals 6, they are similar. The ratios are equal and the triangles are similar. Triangle ABC is similar to triangle DEF. Another way you can write this is by putting a triangle sign, ABC, with this little squiggle. This means similar to triangle DEF. So let's look at another one. We need to determine if the following figures are similar by comparing their corresponding sides. So here we have parallelogram LOMN and parallelogram PQRS. So we have LMON and PQRS. So in this case, we have LO, which is 12 inches, and we have LM, which is 16 inches. In the next parallelogram, we have PR, which is 30 inches, and we have PQ, which is 40 inches. So now we're going to set up our unit rate. So we have, not our unit rate, our unit table. So we have 12 to 16. Actually, we're going to do the letters first. So let's do LO and LM, and LO is the same as PR, and LM is on the same as PQ. So what is LO? We said it's 12 inches. LM is 16. PR is 30. And PQ is 40. So we need to determine, how are these similar? Well, how do you go from 12 to 30? What do we multiply by to get from 12 to 30? Let's see. 12 can be divided into 32 times. So we get 24. We get 6. Annex a decimal and 0. How many times can 12 go into 60? This is 5 times. 5 times 12. Let's see. Check our work. Yeah. So we get 60. So we get a remainder of 0. So 12 times 2.5 is 30. Is 16 times 2.5, 40. Let's see. 5 times 6 is 30. Carry the 3. 5 times 5 is 5. 5 times 1 is 5. Plus 3 is 8. 2 times 6 is 12. Carry the 1. 2 times 1 is 2. Plus 1 is 3. 8 plus 2 is 10. Carry the 1. 3 plus 1 is 4. I move 1 decimal place. I get 40. So yes, 16 times 2.5 is similar to 40. So parallelogram LMNO is similar to parallelogram PQRS. Next one. So we're determining if the following figures are similar by comparing their corresponding sides. So if you did this the same as you did the last one, you should set it up as so. AB is in AD. AB is similar to EF. AD is similar to EH. AB is 90. AD is 150. EF is 35. And EH is 50. How do we go from 50 to 150? Multiply by 3 is 35 times 3, 90. Let's check. 5 times 3 is 15. 3 times 3 is 9. Plus that 1 is 10. So is this times 35 times 3, 90? No. So these two are not similar. So A, B, C, D is not similar to triangle EFGH. Now we're finding the missing side lengths. So to determine the missing side lengths, the number for a set of similar figures, set up a proportion and solve for x, the missing side length. So here we have 3 inches and 8 inches for one parallelogram, and we have x and 16 for the other. So we're looking for x. Well, how do you go from 8 to 16? You multiply by 2. We have to do the same thing to the top. So 3 times 2 is 6. So x would equal 6. Right? So we're determining if the missing side lengths for each set of similar figures. So we have x and 6, and we have 1 and 1.5. Well, how do we go from 1.5 to 6? Let's see. 1.5 can go into 6. How many times? 1.5 times 4, 20. So it can go in 4 times, which is 6. So times 4. What is 1 times 4? We get x equals 4. So now we're going to look at some real world problems. Let's see. Rectangle ABCD has a length of 20 inches and a width of 4 inches. If rectangle EFGH is a similar figure and has a length of 5 inches, what is its width in inches? So the first thing we're going to do is draw a picture. Anytime you get a word problem, it's best to draw a picture so you can better visualize it. So we know it's a rectangle. I'm going to have 2 different kinds. I have one with a length of 20 and a width of 4, and the other with a length of 5. So when we set it up, we have 20 and 4 equals 5 and x. How do you go from 20 to 5? We do divide by 4. 4 divided by 4 gives us 1. So x would equal 1. That is all for today. If you have any more questions, please reach out to your teacher and get some more help, or you can rewatch this lesson video. Thank you and have a good one.